Dimensional Analysis, an instructional step-by-step video. Today, we will be reviewing Problem 7 of the Dimensional Analysis worksheet. To begin a dimensional analysis problem, you must first identify the information that you know. For this problem, that would be the 400 plus bacteria species, one bacteria cell at 5.3 micrometers cubed, and one small intestine equaling 105 milliliters. Once you have identified your known information, you must identify your wants. In this question, we are interested in how many bacteria cells could fit in a small intestine, or bacteria cells per small intestine. With this information, we look for something we want and something we know. In this case, we will be focusing on the bacteria cells. We will use this information to write the first step in solving our dimensional analysis problem. We are now ready to move to step 2, converting micrometers cubed to meters cubed. When beginning your conversion, the first step is to write your prefix followed by its meaning. In this case, we are interested in micrometers, which equal 10 to the negative 6th. The next step is to honor the original units. In this case, meters, which we will be adding to both sides of this equation. The final step is to honor the original power. It is important to remember when bringing the power back in that you cube not only the number, but the unit. This number is now ready to be added back into our dimensional analysis problem. Make sure that you write your units first, and then fill in your numbers. We are now ready for step 3 of this problem, converting meters cubed to centimeters cubed. Again, to solve this conversion, we will find our prefix and its meaning. In this case, centimeters, which equal 10 to the negative 2nd. In the next step, we will bring back our base unit. In this case, meters. For the final step, we will once again be honoring the original power, in this case, cubed. Again, just making sure that when we cube the number, we cube the unit. This information is ready to be added back to our dimensional analysis problem. We begin by writing the units and filling in our number. Now, we are going to ensure that our units cancel out. So far, so good. We are ready for step 4, converting centimeters cubed to milliliters. For step 4, we already know that 1 centimeter cubed equals 1 milliliter. We can take this information and add it straight back into our dimensional analysis problem. Again, make sure to write down your units first, followed by your numbers. We are now ready for step 5 and our final conversion, milliliters to small intestines. As a side note, before you move on, ensure that your units cancel out. Looks like we're good to go. For step 5, we already know that 1 small intestine has the volume, or is equal to 105 milliliters. We can take this information and add it directly into our dimensional analysis problem. Again, write your units and fill in your numbers. Ensure that all of your units cancel out. and make sure that you are left in the units you are looking for. In this case, we were hoping for bacteria cells over small intestine, and that is what we are left with. We have confirmed that we are in the units that we want to be. Now we are ready to move to step 6, putting this information in our calculator. It is important in this final step to ensure that all of your information is correct. Make sure when putting your numbers into the calculator that all of your parentheses match up and that all of your numbers are to their correct powers. You should now have the number 1.981132 times 10 to the 13th. Remember, the correct answer will be in two significant figures, so your final answer should equal 2.0 times 10 to the 13th bacteria cells per small intestine. Thank you so much for working through this problem with me, and I hope you have a fabulous rest of your day.